Hi and welcome to my channel. I have prepared this video for my students and also for you. So let us look at biochemistry of amino acids. But before we proceed, kindly subscribe to my channel. Also share my video so that others can view it. So what are amino acids? Amino acids refers to the building blocks of proteins. Do you remember the word monomers and polymers? Yes, so amino acids are monomers of proteins. So there are over 200 amino acids, and out of this, only 20 of the amino acids. There are over 200 amino acids in nature, but only 20 serve as building blocks. So out of the 20 amino acids, 19 are chiral. The meaning of the word chiral is they are made up of chiral carbon. So we are going to look at chiral carbon in just a few minutes. So amino acids are carboxyl. They have carboxylic acid group, a hydrogen atom, and a side chain. So we have a central carbon, amino group, carboxylic acid group, and a hydrogen atom. And another part that is normally found on an amino acid is the side chain, which is normally denoted by letter R. So it is this side chain that differs from one amino acid and the other. And this side chain is the one that is used to classify amino acids because they differ from it. So any amino acid is made up of carboxyl group, amino group, and a hydrogen atom. So what differs from one amino acid and the other is the side chain. So once again, the side chain is what distinguishes one amino acid from another and usually forms the basis for classification of amino acids. So let us come here and learn how to draw the amino acids. So before we start drawing amino acids, I want us to focus on this word, alpha amino acid and chiral carbon. So from the basic organic chemistry, I don't know if you can remember this, the meaning of an alpha carbon. So if we have this carbon, and it's a carbonyl carbon refers to a carbon atom that is attached to an oxygen through double bond O. So if we have this carbon, any other carbon that is attached to it is referred to as an alpha carbon. Any carbon that is attached to a carbonyl carbon is referred to as an alpha carbon. So assuming that this carbon is also attached to an oxygen atom that is deprotonated, this becomes a carboxylic acid. Remember, amino acids are also carboxylic acid. So we say that this carbon is an alpha carbon because it is attached to a carbonyl carbon. So let us learn how to draw the 20 amino acids. So let's begin by this. There are 20 amino acids, but we shall be drawing them in groups. So the first amino acids that I would like us to draw is this: glycine, alanine, valine, leucine, and isoleucine. So let's begin with glycine. So before we start drawing, I have just said that all amino acids have got this structure in common. What differs is this R. So for us to draw glycine, you will realize that the only difference in the R structure that distinguishes glycine from other amino acid is that the R group is made up of hydrogen atom. So glycine is the simplest amino acid to draw. You just write letter H there. So this is glycine. In chemistry, it is denoted as G, L, Y. So let's look at the next amino acid, alanine. Alanine. So the side chain of alanine is a methyl group, that is CH3. Alanine. So alanine is denoted as ALA in chemistry. We got the next structure. The next structure is valine. The next structure is valine. So we've drawn glycine, alanine, then next structure is valine. For you to remember valine, valine forms a V shape. It forms a V shape. How do we draw a V? Like that, then like that. So valine, it has two methyl groups like that. That are connected to a carbon atom, which is now connected to this structure. So for us to draw valine, you draw that carbon that forms a V with the methyl groups like that. But you also need to remember the rules of the structure and bonding. That carbon atom is supposed to be made up of 4 different bonds. So not 4 different, but it's carbon atom. Any carbon atom is made up of 4 bonds. So this is 1, 2, 3. So the other bond is filled by a hydrogen atom. So that is valine. Then the next one will be leucine. The next structure will be leucine. Leucine has got an addition of CH2 here on the valine. So let me draw valine very fast. So for us to draw valine, draw the extra carbon with the CH2 like that. Then you add it here. So it will be carbon, 2 hydrogen atoms. Then we take back our methyl groups like that. So that is leucine. So leucine is denoted as LEU. So the next structure is isoleucine. Isoleucine. Isoleucine is denoted as I, small l, small e like that. Isoleucine. So we've just drawn leucine like this. Let me just, this is carboxyl group. This is our hydrogen atom. This is our amino group. So we had our leucine like this. Our leucine like that. So that is our leucine. So isoleucine, from the word iso, you need to know that isoleucine is an isomer of leucine. So isoleucine is where this methyl group is transferred to this third carbon from the terminal end. So the methyl group is located on this, like that. So this is, first of all, let me draw leucine first so that you can understand what I'm trying to say. So this one is leucine. So to draw isoleucine, you transfer the methyl group to this carbon, and then this hydrogen atom comes back here. That's an isomer. So to draw isoleucine, you switch this methyl group to that position and this hydrogen atom to this position. So that's what we are doing at the moment. So this one becomes a methyl group and this one becomes a hydrogen atom. So don't forget that a carbon atom is made up of four bonds. So that is it. So those are the first 5 that I have drawn. So let's go to the next. I want us to draw serine, cysteine, and threonine. Serine, cysteine, and threonine. So when you look at serine, cysteine, and threonine, you need to remember alanine first. I'm sorry, I have deleted the basic structure, so let me redraw it. This is our amino group. This is our carboxyl group. And this is our hydrogen atom. So we want to draw serine, cysteine, and threonine. So it's very simple for you to draw serine, cysteine, and threonine if you remember alanine. I say that alanine is drawn like this. So we begin by drawing our basic structure. This is our amino group. Just remember this is 3, sorry. So this is our amino group. So remember that for alanine the side chain is a methyl group. So for serine has got a hydroxyl group in addition to this methyl group. So to draw serine, I must begin by drawing alanine. Let me use my glue. So we must start by drawing alanine like that. Then the only difference between serine and alanine is the presence of hydroxyl group here. So that is serine. Serine is denoted as SER. Then let's look at cysteine. This serine, cysteine. For cysteine, in place of hydroxyl group, we have a sulfur atom that is attached to S, a thiol group that is. So that one is cysteine. The next we are going to look at threonine. So for threonine, we have our we have an OH. We have an OH here. Sorry. That is threonine. So for threonine, we shall have an OH and a methyl group. So those are the next three. So if we add 5, we get our 8. We have drawn so far, we have drawn 8 amino acids. So we go to the next. We have some other amino acids that have got a benzene ring attached to them. So we are going to look at phenylalanine, tyrosine, and also tryptophan. So alanine is a very important amino acid. That is alanine. So we are going to look at phenylalanine. From the word phenylalanine. Phenylalanine. This is an alanine that has got benzene ring attached to it. So we shall draw our alanine. Remember, our alanine is like this. So for phenylalanine, we remove one hydrogen atom. Instead of CH3, it becomes CH2, and then attached a benzene ring, like that. So that is phenylalanine, which is normally denoted as PHE. Phenylalanine is denoted as PHE. We go to the next amino acid, which is tyrosine. This is phenylalanine. So tyrosine is phenylalanine that has got a hydroxyl group. So for you to draw that tyrosine, you need to know phenylalanine and then add a hydroxyl group. So it stops being tyrosine and it stops being phenylalanine and becomes tyrosine. So we proceed very fast. We go to the next amino acid, tryptophan. So for you to draw tryptophan, these are also alanine derivatives, the ones that I've been drawing. So to draw tryptophan, we need to have our alanine that is attached to a 5-membered ring. It is attached to a 5-membered ring like that. We call it an imidazole ring. So we shall have our 5-membered ring, which is an imidazole ring. Sorry, let me redraw. So we shall have our 2 nitrogen atoms like that. And so this 5-membered ring is also attached to a phenyl group. That is, it's also attached to our benzene ring. So that one becomes tryptophan. So we draw the next amino acids, still basing on this basic structure. So the next groups will be methionine, glutamate, and glutamine. Let me just draw them here. This pen of mine is missing. So we shall have methionine, glutamine, glutamate, methionine, glutamine, and glutamate. So for methionine, this we have two CH2s. And one methyl sulfur atom that is sandwiched between some methyl groups. This one is a methyl group. So that is methionine. Denoted as met. We draw the next amino acid. That is glutamate. So glutamate has addition of two carbon atoms, and the two carbon atoms have got the last carbon atom has got the carboxyl group. So for us to draw the glutamate, we know that this is an acid and the CH2. So these are two CH2s like that, then the carboxyl group like that. So that is glutamate. Glutamate. I want to use this, sorry. Glutamate. Then another one is glutamine. 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 So glutamine, from the word glutamine, it has got amino group. So the amino acids that end in Ne, they are basic amino acids and they end with amino groups. So to draw glutamine, we will delete one oxygen atom and add it here. So this one is a basic amino acid. Then we have asparagine. The only difference between asparagine and glutamate is that asparagine has got, is less one CH2. If we remove one CH2, we get asparagine. So let's see. We just remove this. So asparagine is like that. Then the last carbon as that. Then it has amino group attached. That is aspargine. The difference between glutamine and glutamate in short form is glutamine has got GLU. This is glutamine. Then glutamate is GLU. That is glutamate. Then glutamine has GLL as the short form. So our next amino acid is histidine. So histidine has an emitter. The emitter ring, that is a 5-membered ring like that. And this 5-membered ring it has those hydrogen atoms. Each one of them is the amino group, that is NH group. So that is its functional group. Then next will be, this is histidine. Histidine, denoted as HIS. Then our next amino acid, which will be the last one, is proline. So proline, we are going to draw it independently. Proline is like that. It has a carboxyl group like that. And because you need amino group, so that is a nitrogen atom and a hydrogen like that. So in this case, we are supposed to identify a chiral carbon. So we said that a chiral carbon refers to a carbon atom that is attached to 4 different types of groups. So in this case, this is a chiral carbon because it's attached to carboxyl group. This is one of the group that is attached to, then amino group, then this other group. This is the R group, and you can even draw this R group. That's a carbon atom. It's attached to carboxyl group, then amino group, remember when we don't have a hydrogen on a cyclic compound, a hydrogen atom is normally silent. Then we have this other group, this R group, it has a CH, this is CH2. This is HH. This one is also CH2, that's HH. This one is CH2 also. And then this CH2 is the one that is attached to the amino group like that. That's why it becomes cyclic. That's why it becomes cyclic. Thank you very much. That's how to draw the amino acids. What we shall do is to go through now. You need to understand the summary of how to draw the amino acids. So we've said that amino acids refers to carboxylic acids that are attached to amino group. or they are the building blocks of proteins. We can also call them the monomers of protein. Then what's the chiral carbon? I've just said that chiral carbon refers to a carbon atom that is attached to 4 different groups of atoms. Then we also have an alpha carbon, because we say that out of 20, 19 of the amino acids are alpha amino acids. So we've said that an alpha amino acid refers to amino acid that has got one of its carbon atom attached to a carbonyl carbon. So in this case, I'm just trying to remind you something about these amino acids. I've just said that 19 out of 20 are alpha amino acids. So which one is not are chiral, while the rest are not chiral? While one of them is not chiral. So which one is not chiral? It is glycine. Why do you think glycine is not chiral? Glycine is not chiral because this carbon is not attached to 4 different groups of atoms. Two groups of atoms look alike. So out of the 20 amino acids, glycine is not chiral. Then I've also said that the side chain is what distinguishes one amino acid from another. And I think that one you have seen. Thank you very much and have a good day.